So everybody, welcome to another Data36 live webinar. I'm Tommy Mester, and today I'm going to talk about three things. The first part of the webinar will be a presentation by me, and I will show you 4 data science hobby projects that I think that are a good fit for aspiring data scientists. So if you need inspiration for your first or next hobby projects, this will help. I think it will definitely help. And of course, we will have the Q&A section. If you have questions right now regarding anything in data science and regarding the presentation or regarding the 6-week course, so regarding really anything that you think that I can help you, please go to data36.com/questions and ask your questions, and I will answer right after the presentation. And in an hour, and this will be the third thing, in an hour I will launch my 6-week data science course. I will talk about that in a second. But first, again, the link is data36.com/questions. This is where you can ask your questions. It's a nice Q&A surface. I see that questions are starting to flow in. Cool. So far we have 4 questions. So I will just show you. This is this surface. data36.com/questions. You can ask your questions. And just a few words about the course. So I call this course the Junior Data Scientist First Month course, and I think most of you who are in this live webinar are familiar with it because you signed up probably to the wait list of this course. And I think it's a pretty cool course. It's a 100% practical online course, and the whole idea behind it is that it's not just, it's not just giving you random tasks and examples, but it's more like a 6-week simulation of being a junior data scientist at a true-to-life startup. So the whole course is inspired by my junior years at startups where I worked at as a data analyst or a data scientist, and I've collected the tasks that I have done. I generated a data set for it, very similar to a real-life startup, and I put the whole thing into a 6-week course where you will have to go through this as a big case study, a 6-week case study, and I think that with that we cover a lot of useful things within data science. And I think it's certainly one of the most real-life like data science courses out there right now. So obviously I like it a lot, but what I've seen that previous students liked it a lot as well. If you haven't heard about it yet, please go to data36.com/JDS and check out the landing page. As I said, just in an hour I will launch this course. This will be the last cohort in 2021, so the last cohort this year, and next year I will probably open this course only once or twice, but next time probably in March 2020, and I will also raise the price of this course next year. So this is the last time you can enroll this course for $497. Anyways, I don't want to talk too much about the course. As I said, most probably you know it already. If you don't, check out the landing page, data36.com/JDS. And with that being said, let's talk about today's main topic, which is the hobby projects that, well, hopefully at the end of the course, these will be 4 hobby projects that by the end of the 6-week course you will be able to do by yourself. But again, I mean this presentation to be an inspiration for you if you want to start your own hobby project. So really, this is just 4 examples that we have worked, by the way, with students, with ex-JDS students in the last few months, and I just wanted to show you these. Okay, 4 data science hobby projects that a junior level data scientist should be able to do. So these projects are specifically selected that if you want to become a junior data scientist, and I think most of you in this live stream want to become a data scientist, when you can do And when you can get down these data science hobby projects, that's also a good sign that you will be able to do a junior level data scientist job. So this is sort of a test for yourself as well. But again, as I say all the time, data science hobby projects are cool because and useful because with them you can present your skill set when it comes to job applications. So if you put the code base that you create for these hobby projects on GitHub, you attach it to your CV, you send in a presentation and or you upload a presentation to GitHub and attach it to your CV, that will make you stand out. And if your hobby projects are exciting as well, most probably the job interview process somewhere will be about these hobby projects as well. So I remember when I applied to companies, it was much more fun to talk about these hobby projects that I have done uh, with the interviewers than just talking about random data science facts. So I felt much more comfortable in that situation. So long story short, I talk about this a lot. Data science hobby projects are great, and if you haven't done any before you apply to your first job, you should do at least one or two of these hobby projects. So what are the best hobby projects in my opinion? I will show you 4 examples. The first one is scraping and analyzing IMDb. This is just one example, of course. You can scrape any other websites, but IMDb is great because, everyone can relate to movies. It's a popular thing. And yeah, I will talk about that later. You can analyze stock market data simply because there is a lot of stock market data available easily for everyone who has a computer. You can analyze real life businesses. Of course, this will be a bit more complicated, at least to get the data set. And you can generate a data set for yourself. But I will show a concrete example that I have done and that a previous JDS student have done in the last few months for each of these. So let's start with the first one, scrape and analyze IMDb. Okay, as I said, you can scrape many websites, but I think that IMDb is great because everyone loves movies. So if you add a hobby project like this one to your portfolio, there is a good chance that that there will be a good discussion about this hobby project, that what your findings mean, and so on and so on. Also, it requires a few important skills that a data scientist has to have. More specifically, you have to scrape the website in Python, you have to get the data by yourself, and you have to come up with interesting and useful findings. First off, how to get the data, how to scrape a website, any website, not just IMDb. There are many solutions for that. I personally find the best fit for a junior or aspiring data scientist is to use web scraping, of course, but specifically use the Beautiful Soup library, Python library, because it's a very well written, very easy to use. Of course, if you know coding, if you know Python, it will be super easy to get started with Beautiful Soup and start to apply it. So you will need that library. You will need another library called Requests. This is not a web scraping tutorial today, but if you want to learn about web scraping, there are 3 or 4 tutorials specifically about Beautiful Soup on data36.com. So you go and check those out. But the point is that I think that this is the library that you should get started with if you want to scrape a website. Again, it's not too hard to use and it's very user friendly. Of course, it won't be easy either because in data science, nothing is easy. So this is just one example, what you see here, of scraping IMDb's top 100 list. The top in this example, in this specific example, I scraped the top 100 rated movies on IMDb, and as you see, it's already like 20 or 30 lines of code. So it's definitely not like a one-click solution, but you know what? I can actually show you the whole Jupyter notebook that I have created for this one. But first, and I will show that in a second, but first I want to show you the expected output. So we discussed the beginning of the process. How do you get the data? You use the beautiful soup library and you run it on the website. And then the end of the process, the expected output, should be something simple. But again, since we are preparing with these data science hobby projects to a job interview, I think it's best if you can add something that is simple but exciting and nothing complicated here. So in this project that I have done, I've checked out the ROI, the return on investment of the different movies in the top 100 list. So I basically checked the budget of the movies and the gross revenue of these movies, and I scraped this data for each and every movie, and I checked out the average ROI number for each and every movie, and I've created a histogram of that. And as you can see, most movies score around 1 to 5, maybe in average 8 or 10 when we are talking about ROI, and there are a few movies that score like a 40 fold ROI or a 70. Anyway, it's not about the exact numbers. It's more like that you print something, and when you go to the job interview, you can talk about that. Okay, if you thought that big movies bring like a 100 ROI or a 200 or a 1,000 times growth revenue compared to the budget, then you are wrong, because they only bring like a a 10 times ROI. You can plot a scatter plot, so you can figure out correlations. In this case, I again went with budget versus revenue, and as you can see, there is like there is somewhat there's I cannot remember the exact numbers, but I think it was like a 30 or 40% correlation between budget and revenue. So yes, budget and revenue are somewhat correlated. Again, it doesn't matter whether they are really correlated or not. I mean, of course, from data science perspective, it matters. But what matters is that it's an interesting fact, and you can talk about this again. And how did you apply this? How did you approach this problem from a data science perspective? Okay, I thought a bit too much about this project. But this is a great one. I think scraping a website, and again, IMDb is a good start. How much of work is this? For me, the whole project was 4 or 5 hours of coding. So I think that for a junior or a soon-to-be junior data scientist, it's about 20 to 30 hours of work. And I think that's a realistic target when we are talking about hobby projects. All in all, after cutting all the slack, it was around 150 lines of Python code. And the hardest part in this project, of course, is the scraping itself. And for this project, let me just show you the code itself. I won't go through line by line. As I said, it's like 150 lines of code. I just want to show you this, so you can imagine that how much work was this. So first I imported the right libraries, then the scraping part itself. So when I scrape the website is pretty much most of the notebook. So this is scraping, still scraping. Now here I scrape the individual movies. So for instance, this is the Shawshank Redemption's, maybe this was the budget, $25 million, and this was the gross revenue. So again, ROI is not too high on this movie. It's much better for Godfather. Anyways, we are still scraping, a little bit of data cleaning, then a little bit of scraping, and we are still not at the analysis part yet, although we are at like the 70 or 80% of the notebook. So scraping, 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 data cleaning. We bring this whole data to pandas, and like the very last 10% of the work was the actual analysis. So I created top lists about the best and worst ROI movies. Um, I created those charts that I have shown you, so revenue distribution and ROI distributions. I created this correlation analysis charts, and I did some distributions on the year-to-year analysis. And this is it. So the point is that most of this project is about scraping, and like 10 or 20% of the whole thing is the actual analysis. But it's good to know that the expected work hours will be like 20 to 30 hours if you are a junior. Okay, in the meantime, if you have any questions, don't forget that you can ask at data36.com/questions, either regarding this project, either the next ones, or anything regarding data science. And I will move on to the next one, analyzing stock market data. And this is one of my personal favorites because I really like the stock market. I mean, I'm not a big investor or so. I just really like the amount of data that is available in the financial world, like literally every second, thousands, 10,000s, even million data points are becoming available. So it's a lot of data. So for data scientists, it's sort of self-explaining that you should, or you could, but you also should, to dig into this data set. And the good thing is that most of these data sets are, if not 100% available, but like partially available for everyone for free. So you don't have to worry about like paying big bucks for getting this data. What I will show you here is the simplest solution to get daily data about stocks and other financial assets. And for that, I use the Y-Finance API. Y-Finance refers to, first off, it's not an official package. It's an official Python package, but it's not an official package created by Yahoo Finance. Y-Finance refers to Yahoo Finance, and really what it does is this Y-Finance package, it's just reads, sort of scrapes again, Yahoo Finance's website, and it can get the data about different assets, and you can analyze them. And I think the best it can do is a daily level data, so it can get the data on a daily level. But if you want to get like other kind of financial data, you can usually check out different APIs. So if you are into the crypto world, you can go to coinbase.com, or you can Google for the Coinbase API, and you can pretty much get, if not historically, but in real time, you can get like a minute-to-minute data about all the cryptocurrencies that are out there, or at least on Coinbase. And there are like a lot of APIs like this one. Now, of course, working with the API is another skill that you will have to learn. It's not that difficult. It feels difficult for the first sight, but it can be handled. But the point is that for this specific project, you will have to learn the Y-Finance API. Again, it's not too hard once you know Python. The expected output. So the expected output is well, in this case, first, of course, again, you will have to figure out something that's exciting regarding stock market data. It has to be simple, but useful. And in this example, I checked out the correlation between different assets. So I'm not sure that you can see it, but I queried, for instance, the daily data for the Tesla stock, for the NIO stock, for Bitcoin, for Ethereum, for Amazon stock, for Twitter stock, for Facebook stock, and so on. And I downloaded all this data and I checked how much these assets are correlated, the price changes of these assets are correlated with each other. Um, and I created this big table of it. And the point of this project, again, is to show some exciting things. For instance, here, this is just one single example from this notebook. So here, as we can see, Facebook and Amazon stocks are pretty much correlated. Not 100%, of course, but more than two random stocks. So Facebook and Amazon stocks are correlated, which is sort of self-explaining again. Both are big tech stocks, so probably it they are bought by the same audience, or even they are in the same indexes. But it's also interesting to see uncorrelated stocks and different financial assets. And here I found, based on my table, 6 different assets that are uncorrelated. And the message was here that knowing this data and doing this analysis, you can build a more diverse portfolio. Of course, this is not financial advice, so but it's more like an interesting thing to talk about during a job interview, and why you have done this analysis and what do you think about this and how you can apply to another situation this thinking process that you had here. How much work? This is a little bit less work, at least for me it was a little bit less work than it was for the IMDb scraping project. So it was 2 or 3 hours of coding, and for a junior my estimation is like 10 to 20 hours of work. It was 80 lines of Python code, and there was a lot of repetition in it. When I will show you in a minute. And the hardest part, or not the hardest part, but the most exciting part of this one is using and testing the different normalization techniques and correlation analysis. So this little bit more statistics related parts of the Python library and of the Python language. And here's the notebook itself. So again, I will scroll through very quickly on this one. So I imported the Y-Finance library. I queried the different assets. Then with a for loop, I queried all the assets that I needed. And then I pretty much just went into the statistics part. So first off, I had to normalize the data sets, because one stock price was moving from 1 to 10, then another stock's price was moving from 100 to 10,000. So I had to use a statistical method to bring this to one scale. And of course, you can do this in many ways. And as per usual, there are wrong ways and there are better ways. And I had to find the best way. And I had to create this correlation calculations, and you can do this again. There are more than one method to do this, and they will return very different results. So I had to evaluate that which one is the best method. But after a while, I started to see the different correlations and the different not so correlated assets. So the biggest part of this task was more like this checking and testing the different normalization methods and correlation methods. Okay, third project. Analyze real-life datasets. And here the hardest part, of course, is getting the data, as I hear from my students. But here are 3 tips how you can get these for yourself. So first off, you can ask friends. Everyone has a friend who runs an e-commerce shop or a startup, or even just a blog, and you can ask your friend to give access to the data, and in exchange you can say that you will find for them useful findings when you analyze their data. So that's one. Obviously, it doesn't work every time because of privacy issues. People don't really like to give out the data, not even for friends, not even if you sign an NDA. Um, but sometimes it works. So if you have a friend who runs an e-commerce business, you can go to them and say that you will analyze their data for free. Um, yeah. The next one is Kaggle. Kaggle is a it's a big website, but there is a part of it, a very specific and useful part of it for aspiring data scientists, where you can enroll in different data science competitions, and in these competitions, real life businesses anonymize and publish their data sets, and they give out specific tasks. Um, I think, but I'm not sure, that a famous Kaggle project was when Netflix uploaded their data and they wanted to create or ask the different Kaggle participants to create a more efficient recommendation engine for their movies, and I think the price was like some $1 million. I don't want. Okay, I haven't fact checked that, but the point is that if you go to Kaggle, you will find real life businesses data sets. It will be anonymized, but you can take advantage of the fact that there is a competition and you can use these data sets for your data project. Or you can simply go to Google and search for open datasets, and I think the first place that you will find is the Google Dataset Explorer website. Yeah, there is a website called Google Public Data Explorer. That's the exact name of the website. You can go there and search for different datasets, and you will find real life businesses datasets there as well. The point is, once you get the data, it will be your job to find something interesting. For, let's say it's a friend's business, you want to find something interesting and exciting for that friend. If we are talking about an online business, I analyzed an online business, of course, because that's the data that I can get. I think in almost all cases, when you analyze an online business's data set, you will want to do a funnel analysis, you will want to do some segmentation, you will want to do some trend analysis, so timelines, and some sort of ad hoc analysis. Uh, in this case, I analyzed Data36's data set, so I checked out that how does it look like the funnel of Data36. Then I checked out the very same funnel for each and every article that I have on the blog, so how my Python articles contribute to the conversions on my website, how the linear regression article contributes to conversions on my website, and so on and so on. And for instance, one of my ad hoc analysis was that after how many articles that people read, how many articles people read before they subscribe to the JDS course, so the course that I will just launch now. And it turned out that most people read 1, 2, or 3 articles before they subscribe to this course. Most of them too. So that was exciting. The notebook for that looks like this. Most of this data and most of this data project is, interestingly, data discovery. So when you work on real life businesses data sets, it's not that directed like it was for web scraping, or like it was for stock market data, where you already know that what sorts of data you are dealing with. When you analyze an online business's dataset, mostly you will start with data discovery, and it can take hours. So for me, it was like, I think the 50% of the notebook was only without coming up with any useful analysis. I just tried to check out how the data looks like, what are the most important parts of it, what are the most important pages, what can be my main conversion points. So yeah, with one word, it was data discovery. Once I had that, it was much easier to go for the different analyses, and I created again top lists and the things that I've shown you, um, the different funnel analysis, the different segmentations, the different ad hoc analysis, and so on. So how much of work it was? It was, for me, it was the biggest project. It was 10 hours of coding. For a junior, it might take 40 or 50 hours. For me, it was 400 lines of Python code. And the hardest part is data discovery. But I will move on because there is only one project to talk about, and this is a shorter one, because if you cannot scrape a website, you cannot get financial data via APIs, or you cannot ask a friend to give you data, you can always generate a data set for yourself. Of course, in this project, the hardest part is generating the data, not even discovering it. And I will just show you again one quick example. For my different courses, I generated a lot of data sets. So for this one, this is a random e-commerce stores dataset that I've generated. So of course, this is not a real business. Generating the data takes again a lot of coding in Python. For instance, in this one, I started with different mathematical models. This will be the main shape of my dataset. Then I started to add different parameters here, and then for the different parameters, I added a random generator, and I brought this all together into one huge script with a lot of for loops and what of if statements. And with all these parameters, all these models, and all these random generators, it got together into one huge script that generated like billion lines of data for me. And this is one line of data, and I got like 10 millions of these for this data set. So this is how you generate data for yourself. It's not an easy project, but once you have that, you have a data set that you can run an analysis on. And basically, this is it. These were the 4 data science projects that I wanted to show you. Now let's see how many questions we have here. So it seems that if you go to data36.com/questions, you can ask your questions. It seems that so far we have 5 questions, and I will answer these soon. Okay. Just a quick reminder, guys, that I will launch the JDS course here in 25 minutes. So in 25 minutes, you can start to enroll to the 6-week course that I've talked about. And until then, I hope that I will be able to answer all the questions. Let's start with Rob's questions. Rob's question. Rob, thank you for the question. I will zoom in. And let's see, what do we have here? It seems you used a lot of specific APIs to get data. Do such APIs exist for weather or climate? Where or how can I start to search for such specific APIs? There are a lot of APIs for almost everything, including weather data. The weather data API that I know is called, let me think, what was it? Open Weather, I think. Yes, that it is open weather, and this open weather website has an API that I think it's free. Yeah, here it is. It's free for, well, for a very reasonable amount of data points, and you can do almost everything here. So yeah, I actually used this in a test project. I never really used it like in real life projects, but I played around a little bit with it, and it seemed like working. So I can recommend, and it was free. So openweathermap.org is the website. But generally speaking, there are APIs for almost everything that where there is a data point, there is an API for it. Okay, Vincent, I work in biotech, in the biotech industry as a researcher slash scientist. I have a PhD in biological research and I want to become a data scientist. Is this a good background? Vincent, thank you for the question. I think it's the right background, and I say this because in every cohort of in the last 3 years, in every cohort of the junior data scientists, first month course, I three, one, two, three people coming with a biology background, not necessarily PhDs, all of them, but but yeah, somehow I think that data science and biology are somehow related, if not in the exact method what they use, but like in the thinking process, like how do you approach research, or how do you see the big picture and try to go into details, how you see that everything's correlated with everything. So I think there is like a secret link between biology and data science, but the fact is that many biologists are coming to data science. So yeah, I think it's a great background based on my experience. Uh, so that's great. If you want to go for data science, the next question by Tom Age: is Python more important than R, SQL, and so on? How much are these used in data science, I suppose? Uh, so no, not necessarily. I showed you only Python projects in this webinar, but that's only because for these specific projects, I prefer to use Python. But in real life, like if you think about just the last client project that I have done for a client where I work as a freelancer data analyst, I think like 30% or 30-40% of the job was working in SQL, and like 60-70% was working in Python if we are talking about the coding part. But it, as I always say, SQL and Python are good for different things. In that client project, I specifically use SQL to query big data sets, creating all the joins, um, all the different calculations on the millions and 10 millions of lines. And then I do the more scientific things in Python, like correlation analysis. Um, yeah, mostly in this project, I mostly work on correlation analysis right now. But yeah, this is how I use it. So the simpler calculations that I have to run on big data sets, like joining two tables, that that is a simple method, but at the meantime it needs a lot of computing capacity. If you do it in Python, I prefer to do that in SQL, because SQL is basically created to join. Okay, it's not true, but SQL is very good in joining tables. I use SQL for that, and then Python for uh, working on the smaller aggregated data sets, if it makes any sense. And as of R, I don't really use R, but only because I know Python already. And so for me, SQL, Python, and Bash are the three languages that I really use. Bash for automations, SQL for simpler analytics, for bigger data sets, and Python is more advanced analytics on smaller data sets. How many months does it take to become a data scientist after finishing your 6-week course in average? That's a tough question. Of course, I can't answer this one, but you know, there are great success stories, like someone is finishing the course, uh, does an excellent job on the final test task, because there is a final test task in the 6-week course that I evaluate personally, and applies to a job and get the job in 1 month or so. So there are these great success stories. Then there are other people who work 3, 4, 5, 6 months on hobby projects and apply for jobs right after these 3, 4, 5, 6 months, when they have a ready portfolio. So it really depends. I don't really like to promise to get a job after this course, because this course is not, as I always say, this is not a get a job course. This is a learn data science the right way course, and you know, understand what data science in practice is about. But as I said, there are great success stories, and then there are people who are moving slower, and there of course there are other people who doesn't come to a course to the course because they want to become a data scientist. They are like many marketers, they just want to know generally about data science. So there are many digital marketers who take this course as well. PK, what are the timings of the course? I am having years of experience in application development. Should I still consider doing the course? Good question. The timing of the course, it's a 6-week course. You get 3 tasks per week on Monday, Wednesday, and Friday. And you have, depending on your experience, you will have to work on each projects like 1, 2, or 3 hours, in my opinion. Of course, if you have to learn new things during the process, I link the articles that contains the theory for the tasks. Then of course it will be more like 3 hours. If you know everything already, it will be more like 1 hour. And I will send out the solution videos one day later, so on Tuesday, Thursdays, and Saturdays. You have years of experience in application development. Should you still consider doing the course? I honestly don't know. It really depends on what's your goal. I think that this course is really good at showing the business side of data science and the whole business thinking of data science. If you know coding already, that will be exciting for you. And to be more specific about my answer, yes, there are people with a developer background coming with this course historically. So ex-students, there were developers who took the course and they liked the course. So they said exactly this, that they liked the business part, they liked the little extra pieces that filled the different gaps in their knowledge, like someone liked more like the automation part, some people like more the SQL parts of the course, where you know, at the fourth or fifth weeks there are some challenging tasks that I think everyone, regardless of your background, will enjoy or not, but I think those are fun tasks. I'm not sure whether I answered your question. If I didn't, please ask again and ask more specifically, and I will try to answer. Sorry if I haven't managed to answer your question well enough. How bad it looks in a job interview if I can't explain every detail of my hobby project. For instance, if I use statistical algorithms which I don't entirely understand. Good question. It's a little bit bad, but I think that you won't really use statistical algorithms in your hobby projects if you don't read at least a little bit about them, But yeah, it honestly it looks bad. So I think that if you apply a specific statistical algorithm in your, or you know what, I will give you a more concrete example. So if you apply a linear regression, the simplest statistical model or prediction model that you can use, if you apply a linear regression in your hobby project, you don't have to know like the mathematical background on how the line, the formula that how exactly the line is fitted on the data set, but you will have to know the whole theory on how that works, how you can check the performance of your model, and how you can figure out whether it's the best fit for your dataset or not, and why. So when I say that you have to understand your statistical algorithms, you will have to understand on a practical level, like you should understand it on the job. My point is that if you just copy paste everything from Stack Overflow without understanding what's going on there, that's not good, and probably it won't be good for the hobby project either. So again, but it's not a big thing. So when it comes to this, what I mentioned in the webinar, to stock market data analysis, and I have done, for instance, normalization in those projects. I knew a few normalization methods, but I didn't know all of them. So I started to read articles, and I spent like 1 or 2 hours with reading the theory and the big background of normalization. And I'm not a normalization expert, but I'm confident with what I have done in that hobby project just by reading articles. So yeah, I think I sort of over-explained my point here, but if not, again, just ask the question again. Rob asks, from where data36 name comes from? I understand data, nice, but what indicates 36? It's an insider joke for Hungarians only. It's not really a joke, it's an Easter egg, because in Hungary, when you type a telephone number in your phone, which you don't really do anymore because you have already everyone in your phone, but when you actually type the phone number to your phone, you start with +36, which is the pre-caller of Hungary, and that's what 36 refers to. And I'm from Hungary, so that's why 36. And also there are not a lot of domain names with data and anything that were free. Data 37 wasn't free, Data 35 wasn't free, data36.com was free, so I took it. Anonymous question. Tommy, in your experience, for someone that finishes your JDS program, are they able to complete some of the projects you showed us today? Yes, I said these projects were done. We worked on these projects together with ex-JDS students. So yeah, I think that these could be done. Uh, Even more, I created different tutorials for these projects. So um, it was a different course, but parts of these will be given to those students who finish the JDS course on time for free. Um, that's a little extra that I haven't really put. I meant it as a surprise for only those students who enrolled in the JDS course or who will enroll in the JDS course. But some of these projects with a video explanation will go to those students who finish the 6-week program on time. And yes, they meant to be the perfect projects for those who finish the 6-week JDS program. Okay. Do I need to have, John, thank you for the question. Do I need to have mathematical skills to be a good data scientist? Yes, yes, of course. I mean, you don't have to be a PhD in mathematics, but you have to have a basic understanding because you will work with a lot of numbers, of course. The calculations will be done by the computer. Even so, you will have to be able to read the charts, to read the numbers, to read the different calculations, and logic is the most important part of mathematics. I will try to find some of my sketches that I've done for one of my latest projects. I cannot really find anything useful here. Okay, so it's okay. I just won't show this to you. This is a mess. But the point is that yes, you will have to have like basic mathematical understanding, like what is a mathematical function, how it works. To understand the different mathematical functions, you will have to understand probability, how probability calculation works. Yeah, I talk more about this in the How to Become a Data Scientist course. It's a free course. Take that one. Uh, John M. How can I know if maths is a good fit for me while I'm working as a data scientist? Well, first off, to figure out whether maths is a good fit for you or not, you should do that before you become a data scientist. That's very crucial. And I have a very simple method for that. You go to this article, 6 books that I have written on Medium. Aspiring data scientist starts to learn statistics with these 6 books. And it's loading slowly. But the point is that here you will see 6 books and you start to read them one by one. And if you just hate them, then it means that you won't like mathematics, and that also means that you won't like data science. But if you like them, that's a good sign that you will be good in mathematics. So I have this theory that most people who don't like mathematics, they don't like mathematics because they had bad teachers bad mathematics teachers in high school. But these are great books. So again, start to read them one by one. And if you enjoyed them, you are excited about them, the first 3 or 4 are light reads too, then mathematics will be a good fit for you. If you don't really enjoy them, or you are bored, you cannot really get through them, that usually means that you won't enjoy mathematics, which also usually means that you won't be really good in it. And in the meantime, it's 10 o'clock, at least here in Europe, in Central Europe. So I opened the registration for the 6-week course. I will get back to answer the one last question, but I promise that I will open the Junior Data Scientist first month course now, and I have done so. I just have to double check whether it really happened. If you want to enroll, just go to data36.com/JDS. And yeah, indeed, there is the button. Okay, Donnie, the last question by Donnie, and I suppose you are from Hungary. Have you done ever an survey according to feedbacks? I mean, for example, what percentage of students work in data science since they finished the JDS course edited? No, I haven't done any survey, and I haven't done so because it's almost impossible to survey this. If first of all, data scientists don't really work with surveys. There are like many biases when someone fills in the survey. So usually only those people fill in these surveys who finish the course, and out of those, there are people likely to fill in these surveys who actually got a job because they are more proud to it. So it would not be very good statistics to analyze these surveys anyway. But why I don't do this is because I like to do follow-ups with people in one-on-one. So For those students who finish the course, usually we talk like every second month in email, and they email me about something, and sometimes it turns out they got a job, sometimes it turns out um, so there are so many stories. So my point is it's almost impossible to research uh, the success of students in any courses online. Believe me, I as a data scientist, I was thinking about this a lot. It's almost impossible to do that. The only way to do is by having these personal relationships and emailing with students. And again, as I said, there are success stories, but there are many students who don't start this course with the expectation of becoming a data scientist at all. Sometimes they, mostly digital marketers, they just want to have this skill in their day-to-day operations when they work on their stuff. Okay, I hope that this was a correct answer, or this was an answer that helped you to understand what I meant. Um, And Rob says, thank you, Tommy Master. Good night. Thank you, Rob, for joining. And I think with that, I answered all the questions. And guys, thank you for joining. Sorry about the coughing. Again, the air is super dry in this room where I'm at. And it was surprising for me as well. But thank you for joining to the live stream and being with me today. Alessandro from Italy had a comment. Hello, Tommy. Thank you for your webinar. I really hadn't a question to ask you, maybe not yet. I think upon in these days. Cheers. Thank you, Alessandro from Italy for the comment. And thanks for your email earlier today. Anonymous, thank you. This was a very informative session, especially the responses about mathematical proficiency and interest. Thanks again. My pleasure. Thank you for the questions. So yeah, just one last time. If you want to enroll to the Junior Data Scientist first month course, now is the time, data36.com/JDS. This is the last time I open this course this year, and next year I will only open this in March. So next time you can enroll in, if not now, next time you can enroll only in 2022 March, and probably with a higher price. Not probably, 100% sure that it will be with a higher price than right now. So if you consider to enroll to the Junior Data Scientist first month course, do that on data36.com/JDS. But with that being said, this is the end of this webinar. Thank you for joining. Thank you for asking questions. Thank you for liking the video, for everyone who liked the video. And hopefully see you in the course. If not, then see you in another live webinar. I will stop the stream now.